peak lines up with trough lines up with peak, and the waves cancel each other out. It's just like adding positive and negative numbers. Positive 1 and negative 1 equals 0. Negative 1 and positive 1 equals 0. We get cancellation. So this is what the wave would actually look like. Nothing. This is complete destructive interference. The wave has completely destroyed itself. In this complicated example, you can see both constructive and destructive interference happening at the same time. I have this wave moving, and so whenever the waves are in phase, peak to peak, you can see that they add together. However, every other instant in time, the wave here, the peak meets up with the trough, and we get nothing, nothing, nothing. Constructive, destructive, constructive, destructive, etc., etc. That's kind of difficult and tricky to see. But I think you get the idea. Constructive interference is when the waves agree with each other and create a wave with larger amplitude. This is what you would actually see. Here the waves disagree. They're out of phase. They cancel each other out. This is what you would actually see. This, by the way, is how noise-canceling headphones work. Noise-canceling headphones actually cancel sound. Sound is made of waves, by the way. We're going to talk about that. But noise-canceling headphones actually destroy interfering sound by creating more sound. They are capable of creating sound waves which are more or less directly out of phase with all the annoying white noisy sound around you. And the result is that you don't hear any distractions. You only hear the music you're listening to. Every other sound gets canceled out because the noise-canceling headphones create destructive interference, a new wave, a brand new sound wave to destroy the other sound waves, which I think is pretty wacky, crazy, and cool. So waves can interfere with each other in a constructive way or a destructive way. All right, I want you to watch what happens very carefully. You know that if I set this thing going, this little machine will move up and down. I add energy to the system. The energy will propagate left to right, causing the particles to waggle up and down. It's a transverse wave. The particles move up and down while the wave energy propagates left to right. Once the wave energy gets down here, what's going to happen? It's going to be reflected back. And if I keep doing that, I'm going to have waves moving from left to right and from right to left. I'm going to have original waves and reflected waves moving at the same time. And what could those waves do with each other? Yes, they could interfere with each other. So we're going to see that a little bit. It's going to be tricky to see, but then I'll show you another interactive that I think will make it much more intuitive, and you'll be able to see it a lot better. So let's see what happens when I turn this thing on. So I have my incident wave. It's getting reflected back. I have multiple waves moving. I have waves that are being sent. I have waves that are getting reflected back. And if you pay really close attention, something incredibly interesting has happened. I have some points all along this wave that are now hardly moving at all. Look at this red dot. It is oscillating very, very, very tiny amounts compared to here, this red dot is oscillating wildly. This one is oscillating hardly at all, away from equilibrium position. This one is oscillating a total crap ton. So what's happening? Well, I have something very interesting that has resulted from constructive and destructive interference. I have what is known as a standing wave. This might be a little bit easier to see. Let's say that you have multiple waves in one system. You know that those waves can interfere with each other. Well, if the waves are traveling, this wave is coming, this wave has been reflected back, so it's going back the other way. Every so often, the waves will line up peak with peak, but then every so often, the waves will line up peak with trough. You're going to have, in the same system, constructive and destructive interference at the same time. And that results in this. This is what you would actually see. I have points along this wave where my amplitude is at a maximum. And then I have points along the wave that have no amplitude at all. These points are points where constructive interference happens. These points are where totally destructive interference happens. This is known as a standing wave. And it's incredibly important that you are able to determine certain properties about standing waves and that you're able to explain how they are formed. So here's what I say about standing waves. A standing wave is a special wave pattern created through both destructive and constructive interference of reflected waves in the medium. It appears as though the wave energy is not propagating through at all, but rather just standing in place. So let me go back to that and show you what I mean. It's clear to see on my two waves, the incident wave and the reflected wave, that the wave energy is actually moving from left to right, causing the particles to move up and down. With this one, the wave energy has been reflected back, moving from right to left. But this wave down here, the actual result, the standing wave, it looks like the wave energy is not moving at all. It's standing in one place, causing the particles to just oscillate back and forth. It's a standing wave. How are standing waves created? Through constructive and destructive interference of waves in a system. Typically, an original wave and then a wave that's being reflected back, and they constructively and destructively interfere. Standing waves, it's very important that you understand that standing waves only occur at very special frequencies known as harmonics. So I like to show this video. I don't really care about this dude talking, but he has a little machine here that he can plug any frequency into, and it's going to oscillate his string up and down. And what we're going to see, so he's turned it on, it's vibrating the string up and down, and we're going to see him be able to set it to a specific frequency to find a standing wave pattern. Right now, this is not a standing wave pattern. Remember, standing wave patterns only emerge at specific frequencies. He's not at the right frequency. So what we have is kind of a mess of this machine sending a wave this way, the wave getting reflected back the other way. We have constructive destructive interference, but it's not a standing wave pattern yet. He is, in a minute, going to find just the sweet spot, the magic frequency, and right there, bam, we have a standing wave. You see in the middle there's a point that seems to be not moving at all, and then we have points that have a lot of displacement. That is a standing wave. Why was that created? Because he set just the correct frequency. The wave goes down, the wave is reflected back. At just the right frequency, those waves are just perfect to interfere with each other constructively and destructively to create this special standing wave pattern. That's what he's explaining. This video is linked on the website if you'd like to see. Here he's actually touching this point, showing you that there's no motion there. The waves perfectly cancel. He can touch it without changing the system at all. There's at some point, I believe he does it in slow motion. Oh, he's found another standing wave pattern. He's increased the frequency. There's another standing wave pattern. And there's the slow motion. Pretty amazing. Again, this is the result of multiple waves interfering with each other. Waves being sent down, waves being reflected back at just the right frequency to have constructive and destructive interference. That is a standing wave. Pretty cool. Standing waves are my favorite thing almost in all of physics. It's an amazing phenomenon, and standing waves, if you cannot tell from what I've just written, are the underlying principle behind all music. We are going to talk about music just a little bit whenever we discuss sound, but any music that is pleasing to our ear, chords, keys. I'm not a musical person, so I don't really know much about music, but I do know that it is based on the mathematics of standing waves, on harmonics. So once again, standing waves occur only at specific special frequencies known as harmonics, and we're going to talk about those harmonics. Now, before we go any further, there are parts of the standing wave that you must know about. You've got to be able to distinguish these things. The letter L, that is the length of the object that we are analyzing, in this case a string. So the length of the string itself we call L. Then we have the wavelength lambda. You remember what that is. It's one complete up, down, and back wave cycle, including one peak and one trough. And then because we're looking at standing waves, we have special language. You remember that standing waves have these points where there's no oscillation at all, where there's always completely destructive interference. We call that a node. So you can see the nodes here. This one has 1, 2, 3, 4 nodes. And then we have points in between the nodes where there's maximum amplitude, maximum displacement of the particle away from equilibrium position. And we call those the antinodes. This has 1, 2, 3 antinodes. You must be able to identify and count nodes and antinodes. You must know what L is, the length of the string. You must know what wavelength is, the length of the wavelength, one complete up, down, and back cycle, one complete peak and trough. And once again, this is a standing wave. It's actually composed of multiple waves interfering with each other. I'll show this to you one more time. Here are my two waves that are actually passing through the substance, and here's what I would see. Here's what it would appear to be. Can you find the nodes? Yeah, this big black dot right here is on a node. Here's a node. Here's a node. The nodes are where we have zero displacement away from the equilibrium position. We always have completely perfect destructive interference. And then the parts that are waggling back and forth are the antinodes. Those are the parts that have maximum displacement. That's where we get our constructive interference. Make sense? So this is a node, this is an antinode.